Alright, looking at AA. Now this is where I wish I had been a little more careful about drawing this to scale. Because looking at this, 4.9, 0.7, I'm saying to myself, gee, is there some kind of relationship there? I'm wondering, it's not half, so I'm not looking at a 30, 60, 90, but gee, I'm wondering, let's see, that goes in 7 times. 7 times 0.7 is 4.9. No, I don't think so. Maybe not. Maybe it's just Pythagorean. Of course, you're always safe by doing that because you know that if you use the Pythagorean theorem, you're always going to get the right answer. So we're going to go that route. We're going to say that this side squared, so we got AA squared plus 0.7 squared is equal to 4.9 squared. So AA squared, so remember that's just a variable name, so that side squared plus, let's see, 0.7 times 0.7, I believe is 4.9, but double check. So 0.7 times 0.7 is indeed 0.49, not 4.9, is 0.49, 0.49, and then I go 4.9 squared gives you 24.01 equals 24.01. So if I subtract 0.49 from both sides of the equation, so minus 0.49, I wind up getting 23.52. So this side, AA squared, is equal to 23.52. 23.52. Well, as always, the way to undo a square is to square root it. And once you do to one side of the equation, you do to the other. So AA is equal to the square root of 23.52, which is approximately, so if I take the square root of that, I wind up getting 4.85, approximately. 4.85. So that's an approximation. That would be exact. Okay? Alright, looking at BB, well, that's pretty hard to see, isn't it? Tell you what, skip BB because I can't read it, and if I can't, you probably can't. Oh, that's a 5. That's what that is. That's a 5. So let's take away the skip because we are going to do it now. I just have to be a little more careful in my adjusting my glasses. Alright, so here we go. So BB, 5 and 17, I'm not looking at any relationship there that I can see of, so I know that BB, so this side squared plus 5 squared equals 17 squared. So this side squared plus 25 equals 17 squared is 289. 289. If I subtract 25 from both sides of the equation, let's see, 9 minus 5 is 4, 8 minus 2 is 6. So I'm looking at 264 is equal to the length of side BB squared. Square root both sides. So I get the length BB, and if I take the square root of 264, I get approximately 16.25. So BB is equal to the square root of 264, which is approximately equal to 16.25. Okay, so that's BB. Then I got CC. CC, well, let's see. Here is 3. Oh, long side, 3 square root of 3. Short side, 3. Easy. CC is double 3, which would make that 6. So that's CC. DD, Here I have 85, 95. So I'm looking for DD. Let's move this down just a bit. So I have DD squared, DD squared, plus 85 squared equals 95 squared. DD squared, 85 squared. 85 squared is 7,225. 225. 95 squared. 95 squared is 9,025. 9025. If I subtract 7225 from both sides of the equation, I get this length squared is equal, I know 25 minus 7225, 1,800 even. 1,800 even. So the length DD is equal to the square root of 1,800. And if I find the square root of that, it comes out to be about 42.43, which is approximately 42.43. Okay? And finally, the last one, EE. EE. Here I have 1.2, 5.5. Oh, let's see. I'm curious. 2.5. Nope, didn't work. I was thinking that there might be a 3, 4, 5, but that wouldn't be the case. So, not a 30, 60, 90. Not a 45, 45. Not a 3, 4, 5. Pythagorean theorem, here we come for the last time. Alright, so here we go. 1.2 squared plus 5.5 squared. So 1.2 squared plus 5.5 squared equals the hypotenuse squared. So 1.2 squared, 1.2 squared gives me 1.44, 0.44. 5.5 squared gives you 30.25, 30.25, and that's equal to the hypotenuse, the length of the hypotenuse squared. Adding 30.25 plus 1.44 gives me 31.69. So I have 31.69 is equal to the hypotenuse, length of the hypotenuse squared. Square root both sides. So we have EE, the length of the hypotenuse, is equal to the square root of 31.69. So if I take that square root, I get approximately 5.63. So that's approximately 5.63. And that's it, folks.